Alright, so let's continue our tutorial series on the Numpy library by talking about some useful functions or methods in this library. So we have seen ways of creating multi-dimensional arrays from the previous tutorial, and now we'll learn some of the basic built-in functions and attributes that are used when working with our previously created objects, as you can see right here. These are our previously created objects. So we're going to start off with our first attribute. It's going to look like this. So we're going to print. So we're going to have a3 dot and dim. This gives us the dimensions of the defined object, and it gives us 3 because it's a three-dimensional array. The next one we have is shape. So we're going to do a2 dot shape. This attribute gives us the format of the defined object. So 3, 3. A2 is 3 by 3. And the next one we have, so this is a pretty simple pattern. So you have size. It gives you the size, it gives you the number of elements of the defined object. A2 has 9 elements, so it gave us a 9. Alright, so now we have D type. It basically gives element type in the array, D type. And it gives you integer because A2 is an integer. So let's see also with maybe E2's. And let's try E2. It's float. And let's try, I don't know, let's try A7. It's a float. Alright, 64. Alright, so moving on, we also have item size, which gives the size of a single element in the array in bytes. So let's do item size. Let's see, let's change this to, I don't know, E2. Alright, and then we get 8 bytes. Alright, so next we have the method called reshape. This changes the format of a multi-dimensional array. So let's take A1 and shape it into the following. So we're going to say A1. Now we're going to say reshape. And then our arguments are going to be 2, 2. So now we change this one-dimensional array into a two-dimensional array with two rows and 2 columns. Matrix, actually. So if we want to specify some of the dimensions but calculate others based on the previous content of the array, then we place a -1 where the dimension is supposed to be. So if we change this to 3, I don't know, 3, well, there is no 3. So there you go. It basically made a 1 by 1 again. So it's like an autofill feature. So if you want 2 by 2, you just do that. You just do -1 afterwards. Let's actually test that. So this yields the same result as this. Alright, so moving on. If it isn't possible to create a multi-dimensional array from the previous contents, then the interpreter will throw an exception, as you saw. So let's do that with an exception now. So let's do try, and then we're going to print. We're going to do reshape. We're going to try to make it 3 by 3. And then we're going to say except exception as E. And then we're going to say print. So we're going to say, okay, tell me what's wrong here. As you can see, unexpected. Sorry about that. There we go. Total size of new array must be unchanged. So there are two, basically, this new 3 by 3 would be too big for this array right A1. Another useful example we could see is, so let's do A3. And let's do 3, change it to 3 by 6. And it worked. So we took this three-dimensional array and made it 3 by 6. 3 by 6. Excuse me. It should be noted that the reshape returns an object that can be assigned to a variable. Also, there's a method which does the same thing except that it does not return anything, and this method is resize. So reshape returns an object and resize just displays it. So let's do that right now. So we can get rid of this. So we're going to do a3.resize. For some reason there's no autofill here. I don't know why. So we're going to do 3, 2, 3. And then we're going to print a3 with the following 0, 0, 0. And you just get 1. So anyway, this is basically the equivalent of the following. So we could do this. Instead of doing this, what we just did, we do print a3, and then we're going to have some weird syntaxes here. So we're going to have 0, comma, colon, comma, another colon. Then we can have print a3, open our square brackets again, and then we're going to have 0, comma, dot, dot, dot. And then we're going to have print a3, a3, 0. And you get all the results. You get the same results. So let's cut that, print, and you basically get that shape. Alright, moving on. So once we get that, we can also see that it's possible to slice each dimension. So we're going to print we're going to do the following. So let's erase all this. Alright, erase all that. Print, and then we're going to slice. So we're going to say print a3, 1, colon, 3. And we're going to print a3, and then we're going to do 1 by 3, that's a hashtag, comma 0, comma 1 to 3. So basically what we did, we sliced it at these specific places. So maybe we should print this out together so we can compare them. A3. Let's print out a line here so we can see the difference. Print just a string full of lines like that. Alright, so let's see our difference. So what we did here, we basically cut out this first part right here. Alternatively, we can also see this. So print a3. So as you can see, we are basically slicing each dimension in half. So 3, 1 to 3. So we're slicing that one, and we're going to add another print. Let's just copy this line. There we go. And print. Alright, so basically just copied. We cut these dimensions. So basically we cut these dimensions out. So anyway, moving on, an interesting way of accessing elements is through multidimensional arrays that have logical values as elements. So we're going to define a new variable called c1, and it's going to be equal to the following. So we're going to have mp.range 15. Exit that. And from that, we're going to have b1, another variable, called c1 greater than 9. So we can see the array contains logical values telling us whether each element is greater than 9 or not. So if you do a logical value with this range, you will get the following result. So you do c1 hold on, what did I do? Oh, right, A range, not range, my bad, did it again. Alright, and now if we print out B1, you'll get the same result. You'll get a similar result, only this time you'll get all the results, all the elements. You'll get the true value, you'll get the Boolean values of each element. So everything is false up until 10. So all these ones are true as it checks out here. All right, this can be useful in in assignments, for example. So we're going to say now, after that, we're going to say C1 in square brackets B1 equals 1. And then we're going to print out C. And what that did, let me erase this. It replaced all the values fulfilling this condition with this value on the right side, which was 1. So we assign values in this array based on this condition we have in B1. So moving on, now we will go over some methods that look for the minimum, max, as well as the sum values in multi-dimensional arrays. So let's make a new array. So let's call it C2 equals mp.arange. We're using arange now up to 25, and we're going to reshape into a 5 by 5 matrix. So now let's print. We can see the max. It's pretty simple. So C2, you just do max. Just do max. That gives you the max, which is 24 from 0 to 24. That's the max. So, and we're going to see the min now. It's pretty simple stuff. Just like before, if you recall from the min and max functions from other tutorials, you get the minimum, which is obviously 0. So print, and you have the sum, which gets the sum of all elements in the object in this array inside of C2. So we have sum, which is 300. So 0 plus 1 plus 2 all the way up to 24 is 300. We also have the cumulative sum, which looks like this. So there we go. We have that, which displays it adding the cumulative sum up until the final. It might come in handy for whatever functions purpose you need this for. So we also have, you can also do the max based on columns and rows. So you can do C2, we can display the max from axis equals 0. Axis 0 is the row, the column, sorry. And you also have the same thing for, and to do a row, you define it with 1. And if you can also do the same thing for min. You do the same thing for min, right, like that. So axis 0, when axis is 0, you're accessing the columns, and when axis is 1, you're accessing the rows. Oops. There you go. And there you go. So you get the max of each row, max of each column. Max of each column, max of each row. Alright, moving on. You can also do the same thing for the cumulative sum as well. So all you have to do is axis equals 0 for columns, and axis equals 1 for rows. Maybe we should clean this up a little. Get rid of all that. And there you go. Alright, moving on. There are also some other methods used for copying Numpy objects that do not create shallow copies. Now, we explained what shallow copies are in one of our previous tutorials. So please refer to that in for more detail. But basically, a shallow copy creates a copy with the same memory reference, memory location. So when you copy an object and you edit that copy will also alter the data of the original. But what this is going to do, it's going to create a decopy. Wait, no. Anyway, just whatever. Just refer to our previous tutorial on that. Anyway, moving on. Let's define C3 now. C4. C3 equals C2. And now, so these are. Let me just erase all this. There we go. All right, so now we made a copy. So now we're going to say C3 0 equals 15. So when we print, we'll demonstrate. I was trying to explain what the shell copies were earlier. You'll see it right now. So we altered C3, right? But as you can see here, we altered C2 as well. So this is a shallow copy, what we did here. We just set it equal to that. We set equal to the values of that. But if we want to, we can also see this through, actually not but yet. We should all say that but for later. So C is C3. We can check that they are the same, the exact same thing. They just have different variable names. They are the same. So this is a shallow copy. To get rid of this, so we're going back to that but. So to get rid of this, we change C2 to C2 copy up in this first statement right here. So C2.copy. This function is going to allow us to change a C3 without making any changes in the original copy C2. So when we do C2, actually that's not a good example. So let's change this to 16, and it's still 0. And when we do C3, it's 16. So now they're different. And last but not least, we will mention two methods that stack arrays vertically and horizontally as follows. So I think we can get rid of all this now. So v1 equals MP, so we're making two arrays now that are going to be stacked on top of each other. One-dimensional arrays, 1, 2, 4. So back to the beginning. So mp.array, and then we're going to have, I don't know, let's see, 5, 1, 7, 6. All right, and now we're going to do the following. So print. So we're going to stack these vertically and horizontally on each other. So we're going to print. We're going to say mp. So now we're using a new method called vstack. And our parameters are these two arrays, so v1 and v2. And we're also going to do print mp.hstack for the horizontal, and then v1 and v2. Hold on a sec. Oops, that's because the parentheses are bad. Because I am, and we need another parentheses, so 3 parentheses we need. Don't forget those parentheses. Alright, and there we go. So we stacked them vertically on each other, and we stacked them horizontally. Horizontally, basically just add them to each other. Add them horizontally. And that's pretty much it.